Hello everyone, my name is Lisa and I'm glad to see you all at Winter Data Meetup organized by DataZen community. Meet Igar Nakhvat, a delivery manager in data analytics, who will guide you through an essential data transformation journey. In this talk, you will learn how to smoothly migrate from EMR Hive Metastore to Databricks Unity Catalog for better scalability, security, and efficiency. Don't miss this chance to gain expert insights, best practices, and real-world success stories to modernize your data platform. Before we jump into our session, I would like to take a moment to ask for your support in growing our community and recognizing our incredible speakers. If you enjoyed today's discussions and want to stay updated on upcoming events and talks, please take a second to hit the like and subscribe buttons below. Your participation not only acknowledges our efforts, but also helps us reach a wider audience, allowing more people to learn from these insightful discussions. Also, in the video description, you will find the link to the talk page where you can share your feedback, award the speaker a badge, and rate the session. Your input is incredibly valuable. It helps us improve future events and ensures our speakers to get the recognition they deserve for their hard work. Additionally, we would love to hear from you throughout the talk. If you have any questions or insights, feel free to drop them into the chat. Our team will be actively monitoring and we will gather all your questions for the Q&A session at the end. Your contributions make the discussions even richer, so don't hesitate to participate. And now, let's welcome our speaker to share his valuable insights with us. Igor, floor is yours.
Yeah, thank you. Hello, everybody. Thank you for joining today. And we're going to talk about migration from EMR Hive Metastore to Databricks Unity Catalog. The target audience for this topic is data engineers, data scientists, and other IT professionals who are involved into data processing and analytics. I also believe that it will be also helpful even for decision makers who are interested in cloud-based data solutions and want to understand the benefits of this migration for the entire organization. Couple words about myself. I began working with data more than 10 years ago, starting with a single Oracle DB instance that was located right behind my desk. Then I shifted towards on-premise Hadoop cluster, and now I work with multi-cloud solutions. I believe everybody on this call is aware about Amazon EMR itself, but I'll do some quick overview. EMR started more than 15 years ago from Hadoop on HDFS as a main file system. As you can see here on that slide, the latest year is 2021. It's not because of ChatGPT limitations. I inspected all release notes from EMR and haven't found any major features or significant changes. It was mostly security bug features and adding more stuff from open source. So EMR is still up to date. New changes and improvements is releasing, and we're going to talk about this topic later. So what does EMR offer as a storage level? The short answer is a lot. Speaking of about file formats, there are columnar-based formats like Parquet or C. There is row-based Avro, plain text files, and other formats. Also, EMR supports storage frameworks like Delta Lake, Iceberg, Apache Hudi. These frameworks support advanced features like AC transactions, schema evolutions, upserts, and time travel compatibilities. So it's really a lot. In terms of computation, there are also a variety of tools in EMR. There is Hive on 2 execution engines on Spark and TEDS. There is Presta that can combine that data from multiple sources. And there is even Trina, which is actually a fork of Presta. So there, again, there are a lot of tools that solve the same problem of querying the data from the cluster. As for developers tool, there are also native EMR Studio that provide integrated development features for debugging, engineering, and data scientists. There is Jupyter Notebooks, Zeppelin, and of course, Hue for querying and like basic data discovery. And there are even more utilities that mostly came from open source, and AWS packed and shipped them into standard EMR distribution. So in short, EMR is very powerful, customizable, and flexible platform, and it allows engineers to configure a set of technologies that the best fits their requirements. Switching gears to Databricks, Databricks is younger than EMR. The first release was less than 10 years ago. Just a couple weeks ago, this year, Databricks announced Delta Lake first integration with Confluent, with Kafka. So this will bridge the divide between real-time applications and analytics on the platform, which is really nice to have for some project and cases. And Databricks utilize the different approach. I would say it's one task, one tool. Here we can see that Delta Lake is the main storage framework, Apache Spark for computations, and one tool for data governance, unified interactive notebooks. So it's like completely different thing like we saw just before for EMR. So it's mostly unified platform that integrates predefined tool and allow us as engineers to handle a wide range of tasks in single environment, simplifying operations. Of course, Databricks is not the only one choice for migration. There are alternatives, so let's discuss them as well. And the first one is, and the most obvious one, is Snowflake. I believe Snowflake is the main Databricks competitor. They covers very, very similar use cases. There is also cloud integration with the main vendors like Azure, Google Cloud. In general, Snowflake requires less DevOps efforts for the reason that there is even less space for some customization. But with these benefits comes higher cost, especially for storage costs, for the reason that Snowflake does not utilize intelligent tiering, and in petabyte scale project, this difference is very, very huge. And speaking about the cost, in opposite of Databricks and Snowflake, we may go into the open source world where all tools are free to use. There is no vendor fees. There is a huge potential to customization and good flexibility, but as downside, there is no support. It's only community, and it's really difficult to set up and manage the installation. Organization requires good DevOps who will maintain this solution on a daily basis. So for some cases, it's a good option, but I believe many businesses chooses the different way. That's why Databricks and Snowflake are leaders right now. With that in mind, let's explore the key benefits of migration. Why do we need it at all? What is the business purpose for the organization? Because these migrations are not free. It requires a lot of investment, a lot of resources. So the business needs to understand all the benefits. And I'll start from not the obvious one, but I believe very important topic, that EMR is only one out of 200 services in Amazon, while Databricks is the single product and the main product of Databricks company. This means faster feature to market, more innovations and more unique features, and of course, better customer support and better partnership program in order to compete with Amazon. Beside this, right now, Databricks, I would say, owns Delta Lake format and Iceberg format through Tabular acquisition last year. This means that there is more Delta Lake unique features like Unity Catalog, Delta Share, a lot of optimizations like predictive optimization that helps organize data on disk. This year, a couple of weeks ago, they announced automatic liquid clustering, that also a unique feature that simplifies the storage and also nice to have. With this comes a unified platform. So it's same environment for data engineers, data scientists, and analysts in comparison to EMR world, when we have separate web application for individual tasks. So it's not too handy to support and work with like different web applications. So one is always better than tons of different stuff. Rather than that, there is very good optimized configuration out of the box. So forget about custom memory settings for each Spark job. No need to do this at all. And also with this unified platform, we will see slightly operational reduction, less administration and less DevOps effort required to support and maintain Databricks as a platform. For some cases, it also may be a good choice when data migration is a part of bigger initiative migration. For example, when organization wants to migrate from Amazon to another cloud, Azure or GCP. So this Databricks migration may be the first step and make this bigger initiative simpler through choosing another vendor for data platform. And the last topic from that list is that Matej Zaharia, who is original creator, is still works in Databricks. He is CTO and associate professor at Berkeley. So Databricks in general has better Spark support and more optimization, and this is really good choice for Spark-centric projects. Let's quickly touch on best practices. These best practices are based on real case and the assistance of Databricks architects, so it's not something theoretical. And we will start this topic from metadata because this is like the first point that we need to adjust in our Delta Lake world. Here you can see the DDL4, I believe, standard table in EMR world. This is external table in Hive Metastore. There is partition on column with date stored at Parquet somewhere on S3 location. And in order to unlock the full potential of the platform, we need to add some adjustments into the way how we store the data in our Delta Lake. And this change, including the changes in partition strategy. So Databricks recommend to use liquid clustering instead of classical partitions. There is a way to use them as well if you want in Databricks, but for many cases and for long term, it's better to shift towards liquid clustering. At this point, there are some issues with performance in case our cluster key is string data type. That's why we need to convert it from string to date, because there is no issues with data numbers. So in case in EMR we utilize partition strings, we definitely need to convert them into dates. Other point that we need to put our cluster key on the first place in the table. By default, Delta Lake collects statistic on the first 32 columns. It's possible to tune and change, but in case we stay everything by default and our table has 100 or even more columns, this also may affect performance. So it's better to keep them on the first place and make all tables with similar structure and approach. Okay, we defined the metadata for table, and we need somehow to move a lot of tables from EMR to Databricks. There are a variety of ways how we can achieve it, starting from custom scripts and logic, but I'd like to recommend use Databricks workflows. So workflows is managed orchestration service inside Databricks. It helps us easily define, manage, and monitor the migration jobs. We can easily define parameters for each job, where we can define items like source table name, destination table name, any other additional parameters. Also, there is very good observability capabilities, including alerting and custom webhooks. And also with this web application, it's very handy to work within a big team, where you can share the links and see what is going across the whole project. So the jobs workflow executes jobs, and each jobs consist of one or more tasks, and there is a possibility to add custom flow logic like branching, looping. For our migration case, we may combine tasks related to data movement, data quality, and optimization into one job, and then execute them using the workflows. Let's explore how extremely simplified data migration task may look like. So here we can see pretty straightforward create table from select, where we define Delta format, cluster strategy, do some conversions to date type, as we discussed earlier. Here we can see that our filter is 1 equal 1, which is default for big tables. We may apply more complex filtering logic by some columns in order to migrate one table into multiply parallel threads. So in general, in order to do massive migration, and under massive migration, I mean hundreds of tables, all we need to do is prepare the business logic in notebooks, add these pieces of logic into jobs as separate tasks, and then execute these tasks and jobs using Databricks workflows. Moving on to our next topic regarding the challenges that we may face during this migration. And the first challenge comes with changes that we applied in our table structure in order to unlock the whole potential of Delta Lake. We applied different partitions. Delta Lake also supports limited but still transactions. Now we have possibility to utilize merge and delete plus insert syntax. For example, at this point, we cannot wrap, delete, and insert together in one transaction. So in case insert fails, the table will not consistent. So it's better, for some cases, it's better to use merge, but as downside, merge is not so performant as simple delete plus insert statement. So engineers need to define which is the best way to rewrite the existing logic using new Delta features. During this exercise, we may find that actually syntax is not the same within the platforms. Databricks has a way more built-in functions rather than EMR, and instead of having some legacy UDFs or even custom UDFs, it's better to rewrite the logic and rely on built-in functions. And the last topic from this section, but the most important one, is the constraint that Databricks is able to read and write into Hive Metastore, but not vice versa. So it is impossible to directly read the objects from Unity Catalog from Hive Metastore. With this limitation comes some issues with planning. In case we have a complex dependency tree within the ETL, we can't migrate just one table from the chain. It's all or nothing. For example, if we have 10 tables that depends one of each other and system is live, we cannot migrate just one table. We need to migrate the whole chunk to the new platform immediately in order to comply with this limitation. As a workaround, we may consider a two-step migration. First, we migrate the whole compute workload to Databricks while keeping the metadata in Hive Metastore, and only after that we should migrate this data. We should migrate the data itself. This approach will help us with planning because we can just list all the tables and go one by one, so we don't need to handle complexity chain of dependencies. And the last topic is conclusions. So in general, the choice between EMR and Databricks depends on specific use case requirements, ecosystem preferences, But in case organization decides to go into Delta and Spark world, Databricks is really good choice. There are a lot of Delta and Spark related features and optimizations that helps organize the storage level better and compute faster and paying less for the same amount of workload. Also, Databricks bring very cool unified web app. This is very good collaborative tool and framework. So very user-friendly in comparison with the offering from EMR. As an example, as data governance tool, EMR or Amazon provides Amazon Glue, which is like a separate service for data governance. It has, as any tool from EMR, wider customization and supports like everything, but in case we need to manage the data on Delta Lake, Unity Catalog is overperform Amazon Glue at like every item and topic. But this is not like all good. There are also some like constraints and downsides. The first one is the cost. So if project is looking to another platform or solution to dramatically reduce the annual bill, Databricks most likely will not provide it. It can even be more expensive in comparison to Amazon. So for that cases, it's better to look into some open source solution. But for now, it seems that Databricks will definitely cheaper, especially in terms of storage rather than Snowflake. And for majority of tasks, the final bill will be very comparable to what we have in EMR. Also, we separate like layer of abstraction that brings Databricks because it's built upon another vendor. This is risks that brings vendor lock-in. And comparison with EMR, Databricks has less customization and flexibility, which also may be important for some cases. If you are interested in this topic, here are some pages that I suggest you to review, and that's it from my side. We can dive into questions and answer sessions. Thanks.
Thank you, Igor. Yes, we have a couple of questions for you from our audience. So the first question is, as we heard, Databricks is really under demand. How do you suggest to learn Databricks? How easy to start with Databricks for new engineers?
So the first thing, it's probably Databricks documentation. I would definitely recommend to start inspecting at least the white papers. It's up to date and very good quality. Rather than that, there should be educational programs on major educational portals where you can review some courses and play with these technologies. So self-educations, there are tons of videos on YouTube because like Databricks is very popular nowadays, maybe even the leader. So there are a lot of resources on YouTube and educational programs as well. But the first step is like white papers on Databricks.
Thank you. Got it. But what skills are required to start with Databricks from engineers?
I believe if we're speaking about the data, any background with any databases would be very helpful. Just like the general understanding about databases. Of course, we need person needs to have at least basic knowledge SQL or programming languages like Python or PySpark. So I would recommend to, of course, have this knowledge as well. So SQL, Python, PySpark, and databases in general.
Okay. You say about data migration with Databricks. I know that there are many ready-to-use cloud services for that. AWS Data Migration Service, AWS Aurora. Why do we need Databricks?
Is it about the migration or like alternative technologies?
About migration.
About migration. So, okay, if we're speaking about how we can move the data, anyway, we need to apply some changes and customization. To be honest, I did not inspect the other option. I was interested to do this using Databricks in order to like educate and use this full potential of that platform. So if we're going to migrate to Databricks, and there is tool inside that platform that allows us to do this, from my perspective, it's better to use this tool from Databricks itself.
Okay, but do you have any cost comparison between Databricks and all the alternatives?
To be honest, this cost comparison is a very big topic and like separate talk. If we're speaking about EMR, it brings a lot of customization and some manual tuning. And if we spin up Delta file format, Delta platform on EMR, which is possible, I believe we may build the platform that will be less expensive than Databricks. But these we need to pay for developers, DevOps, in order to maintain it. So it's like really complicated and hard question, and I believe there is like no one answer. It's again case by case, and there are a lot of moving parts. But in general, Databricks will have, I would say, equal cost, but EMR provides more ways to do manual optimization.
Okay, thank you. The next question is how to optimally process and migrate large catalogs with thousands of tables?
During this presentation, I've touched this topic, how to build the process to migrate one table, and this can be easily expanded to 1,000 table. We need to understand, is it live table or static? For example, when we just move the data from static system and then allows analysts to work with that, or this is like the live the live system. So to do that, it's more about planning and working with stakeholders. This is like a separate non-engineering work where we need to collaborate with all the parties and get them involved into the process, because in data world we have, especially in huge organization, we have hundreds of analysts. They have their custom logic dashboards, and we need to at least notify and work with them during this migration to not break the stuff and make their life easier.
Okay, thank you. The next question is how to test such a migration? Do Databricks have some maybe specific tool for migration testing?
In my in my previous backgrounds, and actually I suggest to add data quality step in each migration job. For example, we moved the data using this create table from select, and the next step in our migration job will task that at least will make sure that the number of rows is equal between two platforms. It also can do sums to understand that like the data inside the columns is also the same. So mostly it is possible. It's very easy not to use like some tools, but to write this logic by yourself using SQL or PySpark and integrate this piece into the migration process. But in general, I haven't faced any issues with data, because Hadoop and like Delta formats are pretty dissimilar. The data types are the same, so it should be not so painful as other aspects of the migration. But definitely data quality must be implemented.
Yeah, I agree. Thank you. And the last question for you today. Is it possible to use Databricks as a non-code tool for non-engineers?
Come again, what is the first
Non-code tool.
no
Coding,
yeah, I got it. Interesting topic. So if we speaking about no code, like no SQL knowledge at all, probably not. Like if we're speaking about no code, it's better to, especially for data visualization, it's better to use some other tools like Tableau. If we're speaking about data science and data engineering tasks, there is no like drag and drop features where we can build something using some bricks. So we need to write code. We need to write code. So, and in general, my understanding of this area and the role of analysts and data engineers, that this programming is must to have. Is it like SQL or Python? It will be extremely hard to work in this area without background in these technologies.
Yeah, it makes sense. Thank you very much. Thank you, Igor. Thanks for joining today's discussion. In the description, you will find the link to access the presentation file and recording. Don't forget to say speaker thank you by awarding a badge and rating the talk. Be sure to subscribe to our channels for more content like this, and we hope to see you at the next session of the Winter Data Meetup.